Leave your folders there. All right. So again, these are the questions I got from people in tutoring that they wanted me to go back to. This is, again, out of Springboard, so I'm going to do these in order. And then from Ms. Oswald's worksheets, I got these two questions on the reflection part, number 10 and 11. So I'll do Springboard first because I think she's assigned stuff out of Springboard as well. And then I'll also do those two. So starting with Springboard, page 119. So on page 119, we have a few problems. All right. The first one was number 20B. So on this diagram, you have, it says, draw the reflection of the arrow described by each of these functions and identify the line of reflection. So first thing you have to do is for, let's see, this was 20B. We're going to have to do this. So each one of the points, we're going to change by this outcome. All the y values are staying the same. Now, if you want to show the work for each one, essentially what you're doing, so again, I'm going to write it up here, x comma y, and then I'm doing a -2 minus x comma y. So the first coordinate point at 0, 3 is going to change by doing -2 minus 0, comma 3. So this new point is now at -2, 3. So -2, 3 would be my point for this original point. Then we go to the next one. All right, the next point there is at 2, 4. So 2, 4. We're going to move it to -2 minus 2, comma 4. -2 minus 2 is -4. So we're at -4, 4. -4, 4, that's my new point. Now you can already start to see how the arrow is, because that's this line segment here is right there. If you want to do the rest of the points, you can. Or if you want to go ahead and do your reflection based on what you can already see happening, that's fine. So the arrow is going to end up looking like that. All right. Now, what line are we actually reflecting in? Well, we need the line that all these points are equal distance to. So if you drew a line between these and split the distance, they should fall in the line of reflection. So from here to here, there's a difference of 6 points, all right? 6 units. So halfway is 3. So that should be on the line of reflection. These have a difference of 2. Half of that is 1. So that point should be on the line of reflection. So we have a vertical line that is acting as our line of reflection for 20B. Now, how do you do the equation for a vertical line? Well, for a vertical line, it's going to be all the points at the same x value, and it's passing through the x-axis, right? So look at your x-axis. What point does it go through? It's -1. So our equation here would be x equals -1 for a vertical line at -1. Again, remember, vertical lines will be set equal to x. Horizontal lines will be set equal to y. It seems backwards, but again, that's because those are the points that don't change. Now, the next one that we had was 21. 21, it's still looking at the figure, but it wants to know what. Describe a reflection that would map the arrow onto itself. Well, if you're mapping something onto itself, that's talking about symmetry. Symmetry is where the figure, after a reflection, gets mapped onto itself. So where is our line of symmetry, is what this is really asking. So our line of symmetry would go right through the middle of the arrow, horizontally. So we have to say what the equation of that horizontal line is. So since it's a horizontal line, it's going to be set equal to y. And this would be at y equals +3. And that would be our entire equation for that one. Just y equals +3. Because it's talking about the line of symmetry. All right. 22 was the other one asked on this page. On 22, what is the image of point C under reflection across the line of symmetry? Again, this is acting as a line of symmetry. So if we were looking at C, if it reflects across this line, it's going to end up over there on D. Again, that line that's drawn in, that's the one we're reflecting it across. So it's just asking, where will this point be in the image? Again, image is the new figure. Pre-image is the original. So if it's asking, what point will the image of C be, it'll be on point D. All right. Any other questions there before I move on to the next page? Those were the ones I had on sticky notes.
I think it's 23 and then 24.
23 and 24? All right. On 23, does any point remain fixed under reflection across the line of symmetry? So that means it doesn't move. So A would be the correct point because A is on the line of reflection. Any point on the line of reflection doesn't change. So A, since it's on the line of symmetry, or on the line of reflection, again, when you're talking about symmetry, you can call it line of symmetry, line of reflection. It's the same thing. But here, again, any point on a line of reflection doesn't move. So A does not move. It's a fixed point. On 24. All right, I'll do part of this one. I'm not going to do the whole thing because there's two pieces to this. Which ones would have to be congruent in order for that to be a line of symmetry? Well, all right, so that's one set that has to be true. So ED has to be congruent to BC. And then there's one other segment as well. I'm not going to write the other segment just so there's some other work to do. But there's one other set there that would also have to be congruent. Look at the top of the figure. All right, look at the top of the figure. Yeah, because it has to reflect onto itself. Yeah. All right. On page 126. This one, there is 3 questions that I was asked. 17, 18, and 19. All right. Now, just to say this again, 16, I threw it out. Really, the only one that you can't do on 16 is A, because that one's not centered around the origin. On 17, I told you guys in tutoring, and I'll send out a reminder to everybody else, I told you guys to make the 0, 0 the origin, so it makes this a little bit easier. But essentially, if I was to take that image, which, let me use one of my transparencies here, and I was to trace it, again, you guys can really just turn your pages in your book and make it a little bit easier on yourself. It's hard for me to do that with the entire book attached here, so I'm going to trace this. So I'm going to trace my X and Y axis so that I can see my X and Y axis. You don't have to do this. And then the arrow is right here, right? So now, if I was to rotate this 90 degrees counterclockwise around the origin's not moving, and it goes to right there. So now, my arrow is pointing what direction? Down, and the tip of it is at -3, 0, right? So again, that's my answer. So it's down, and the tip is at, -3, 0. That looks horrible. I mean, just -3, 0. That's for A. The next one, 180 degrees. So you rotate this thing all the way around. And it'll be down here. Again, you could do the same thing, just turn your paper. And then you're going to use the x-axis and y-axis the way that it looks to you now after you've turned it. And your arrow is now pointing what direction? Well, it's pointing to the right, right? Pointing to the right, and the point of the arrow is at 0, -3. So it's going to the right, and it's at 0, -3. The last one, if I did 90 degrees clockwise, so now we're going this direction. So that last one's pointing up, and the arrow's at 3, 0. Let's see, 18. Describe a figure that has an angle of rotational symmetry of 10 degrees. Well, in order to find your angle of rotational symmetry, that's where you take the number of rotations possible and you divide it from 360. So 360 divided by the number of rotations gives you that angle of rotational symmetry. Well, you can do the opposite and divide by the angle of rotational symmetry, and it should tell you how many rotations you have. So if I take 360 and divide by 10, sorry. If I take that and divide by 10, 360 divided by 10 is 36. So I can say a couple things with this. It has 36 rotations of symmetry, or if I want to be more specific, the rotations should correspond to, if it's a regular polygon, how many sides or vertices it has. So I could say it has 36 rotations of symmetry. Or I could say 36 sides, or 36 those vertices. I gotta make that plural. And either one of those, or any of those, should be correct. Number 19, do you think it's possible for a figure to have an angle of rotational symmetry of 37 degrees? So what would have to happen if you had that? Because on the last one, I took the 10 and divided 360 by the 10, right? If I was to take 360 and divide it by 37, what would have to happen in order for this to work? Anybody got an idea?
When they have to go over it one time and then make another, like
Well, okay, so it does have to have more than one rotation in order to do that, because again, it has to be your degree has to be under 360. So that's true. But there's something else. If I take that number and divide it from 360, it has to go into it evenly. If it doesn't go into it evenly, it doesn't work, because you can't have like a part of a side, right? So if I took 37 and divided 360 by 37, you get like 9.7. 9.7 is not a whole number. So this can't work, because if you're getting 9.7, you can't have 9.7 sides to a polygon, right? You can't have part of a polygon. So it doesn't work. It'd have to come out to a whole number. So this degree would have to be a factor of 360 in order for it to work. So no, 37 is not a factor of 360. No, that's all right. All right. So those are the ones I had from Springboard. Are there any other from Springboard before I move on? All right. Let me go to that packet for Miss Oswalt's then. So let me get rid of that. All right. So in Miss Oswalt's packet, we have, let's see. Hold on. It was in the reflection part. You had questions 10 and 11. Oh, that makes it easy, right? One after the other. Let's see. So the directions here are write a rule to describe each transformation. All right? So, on number 10, now, these are reflections. So, again, there's a couple different types of notation that you could do. All right? If you're using the notation that's in Springboard, with like the T, the capital R, and the lowercase r. If we're doing a reflection, that's going to be a lowercase r for reflections. Rotations, capital R. Translations, capital T. So on here, this is asking for what reflection is happening, right? So the reflection that's happening is right here along this line. And the way that we can identify that it's that line is if you look at from K to K prime, half of the distance would be on the line of reflection. So there's 4 units between here. So if you go 2 units, that point has to be on the line of reflection. Here it is 2 units. So that point, that's only 1 unit away, would have to be on the line of reflection. Same thing down here, 2 units. Have that as 1 unit, that would be on the line of reflection. So this is our line of reflection. Now that's an easier one to find. But the actual line here, this would be at x equals 1, 2, 3, negative 3. That's our line of reflection. So it's a reflection across the line x equals 3. So if you were to write this in words, you could say reflection across x equals negative 3. If you're doing the notation, reflection is the lowercase r. So reflection across x equals negative 3. Either of those would be acceptable. All right. What was the other one? 11, right? Yeah. On 11. So 11 is also a reflection. Now, the line of reflection, again, if you can look at it and identify the line of reflection, great. The line of reflection here is on the y-axis. Again, if you need to, you could identify it by looking at the distance between them and going halfway. Distance between these, halfway. Distance between these, halfway. Distance between those, halfway. That gives you your line. Now, once you have that line, again, you could say it in words like I did on the last one. Reflection across, you could say one of two things. Either y-axis, or you could do it as the equation of that line. What's the equation for the y-axis? X equals 0. Now, if you write it in the format that's in the Springboard book, usually you just write the equation of the line. They do sometimes write x-axis as well, so I would accept it either way. I don't know if Ms. Oswald would accept it either way, but I would say either of these would be acceptable because they do use that in a couple places in Springboard where they actually write out y-axis or x-axis. Most of the time, though, they do use it as an equation. And most other books that I see will write it as an equation. So I think in some of the answers they do this. But that's the correct notation. All right? Any other questions from this?
Yeah, on the back of the rotation one.
Back of rotations?
Yeah.
All right, so let's see. Rotations. Which number?
10.
Number 10? All right, so same directions. We'll describe the transformation. They want to know what rotation is happening here. So again, these don't have the primes. So the prime, again, this would be our pre-image. This is our image. Now, if we were to rotate this over here, this is going either 180 degrees clockwise, or you could say it's going 180 degrees counterclockwise around the origin. So, it doesn't matter which way you go, but you could say it's a rotation about the origin, or you could use the actual point, 0, 0, of, and then 180 degrees. And it could be either a positive 180 degrees, or you could do it as a negative 180 degrees, or you could say clockwise 180 degrees, or counterclockwise 180 degrees. Any of those are actually acceptable, because 180 degrees, it doesn't matter if you're going clockwise or counterclockwise, it's still the same rotation. If you were to write it in the other notation, here's where you use a capital R. You're supposed to say what the point of rotation is first. So the point of rotation here is 0, 0, comma, and then the degree of rotation. Now, again, I don't know if Miss Oswald is making you do the point of rotation first, or if she's just having you write this, because, again, some places in Springboard, they don't even write the center of rotation, they just write the degree. It's kind of frustrating when they use so many different things, but I would say either of those are acceptable, or if you just said a rotation of 180 degrees, because again, some places in the Springboard book, they just do that. But again, any of those should be acceptable. If you're using the full correct notation, I would say you should include the coordinate point as well. But again, in some places in the Springboard book, it doesn't do it.
Can you add me?
Yes, I'll add you right now. Any other questions? We good? All right, let me stop this recording.